right, well, welcome back. We are in example number 8 of how to find solutions on an interval of a trigonometric function. So once again, we're finding solutions to trigonometric functions using algebra, identities, all this cool stuff. All right, and in my last video, I just showed you how to do it on a calculator. I'll continue to show you some potential videos like this one as well, how we can solve this on our calculator as well. All right, so here we go. Well, doing this one, this is one that we had similar to this in another one. Well, right here, hopefully you start noticing we have 2 cosine squared of x plus cosine of x minus 1 equaling 0. Hopefully when you see this, you're like, hey, I see this is in quadratic form. Yeah, just like we've done in the past. All right, if we write this up, all right, right as quadratic, we said y equals cosine of x. We can replace and say 2y squared plus y minus 1 equals 0. And that's what we would have, all right? So bring those two, maybe putting in u substitution, or whatever you want to have. But now, if we want to solve for y in this case, very, very similar over here, because we want to solve for cosine. All right, this would be, we can actually factor this, I think. All right, so we have 2y. This is going to be minus 1. And then we'd have y plus 1. All right, and that would be 2. Yep, that would be equal. And so we would have our final solutions, y equaling, all right, what would this make equal 1/2? And then we would have y equaling -1 right there. All right, so those are our 2 solutions where we're going to have our values for y, where y equals cosine. We can do the same thing over here. If we took this, it would be 2 cosine of x, all right, minus 1. All right, we can factor this. Just remember that cosine is what's going to be factored. We have cosine of x plus 1 right there equaling 0. And so using this, we know that cosine of x has to equal 1/2. And also cosine of x has to equal -1. All right, and so what we're going to do is we have to solve this, all right, by finding our different values. So to do so, we have to think about, okay, where's cosine of x equaling 1/2? We're looking for the interval between 0 and 2 pi. If you wanted to go over here, all right, and take this, we could solve for x by taking the inverse cosine. So take the inverse cosine of 1/2. Now the problem is when you do inverse cosine, you only get values between 0 and pi, 0 and pi. However, cosine has 2 different solutions. Because if you recall, when you went back way back in the day, all right, cosine is positive wherever x is positive. Okay, so it's going to be the first and also fourth quadrant. So when we have this, we're going to have an angle here and an angle there. All right, it created a little triangle. All right, right there, and also whoop, all right, right there. And those are the 2 different angles I'm looking for x in order to get this value. Okay, so those are the angles I'm looking for because inverse cosine gives us angles. That's what we have. So if you put this in your calculator, you get a degree measure where we'll have a triangle, we'll have cosine, we have 1 and 2, we'll have a radical 3 there. So once again, this is going to be pi over 3 or 60 degrees. So if you put this in your calculator, you should get 60 degrees. All right, you can try it out. Take x equals inverse cosine of 1/2, you should get 60 degrees. But that is only half of this story because that only gives us part of our answer. So what we're going to do is we're going to have x, yes, it's going to equal 60 degrees or pi over 3. But we also have to get the 1 in the fourth quadrant, so you can take 360 minus, all right, 60 degrees, which gives us 300 degrees. Or in the same token, we can do this by going 5 pi over 3, because that also is going to equal, all right, so we get or 60 degrees or 300 degrees, and that's what we have right there, okay? So those are going to be our 2 different answers that we're looking for. All right, one which is going to be in that first quadrant, and the second one we have to go whoop, because we know that this is also going to be 60 degrees. All right, if you kind of see that, so we have to find out this angle. So if we take 360 minus this reference angle, which is 60, okay, this reference angle which is 60, and that's what we have. Now, if you're wondering how do I get those things, I have previous videos on how we find reference angles and how to use these trigonometric ratios of these basic simple forms of 1/2, radical 3 over 2, right, square root 2 over 2, and so on and so forth. All right, so those are 2 of our solutions. Okay, the next one is how do we find cosine of -1? Now, cosine of -1. So if we go in here, do our inverse trig, because that's how we solve for x. We take inverse cosine of -1. Well, when we punch that in there, okay, we punch that in there, -1, what we're going to have is -1 is going to be right over here. So if you put this in our calculator, we should get 180 degrees, right? Because that's where x is going to be, because cosine of x on y. On the unit circle, -1, 0 is our point over here. And where is x equal to -1? It's only one value, one value. All right, at 1, all right, we have 0. But at pi, so at pi, that's where it's going to be -1. So actually, if you put this in your calculator, you should get 3.14159, or 180 degrees, depending on what setting you have it on. But yeah, this x value is going to equal pi, or 180 degrees. All right, and that, my friends, is our solutions, all right, to this particular problem right here. We have 3 of them, all right, that are between 0 and 2 pi, all right, and that is where we will be, all right. So once again, we factored, we set them up, we use the inverse operations, we use our calculator to solve that, using little math facts, all right, trig facts, trig bits, and understanding where is cosine positive. Cosine is positive in the first and fourth quadrant. So this, where is cosine of x equal to -1? Well, that's only one spot at pi, and that would be our answers. All right, so that's just from 0 to pi, 2 pi. Hope this helps you out. Good luck and God bless on the rest of your problems.